geothermal, biogas, and hydroelectric power too across the state of Wisconsin. We do work on education, policy, and programs work. And tonight we're going to be talking a little more about kind of the program side of what we do here at Renew. And so I'm just going to run through the format a little bit because obviously this is a little bit different than our typical information sessions. I'm going to ask that everyone keep themselves muted just because there can be background noise that might interfere with other people and their ability to hear what's going on. There are two ways that you can ask questions. Actually, I think there's probably three ways. There should be a chat function at the bottom of your screen. So if you click on the chat button, you can just type in any questions that you might have. There also should be on the bottom right-hand side a raise hand function as well. You can raise your hand and we'll let you ask a question verbally, or there's also, I believe there's a, I think it's an emotions button. I can't see it on mine, but there's a way you can kind of put your hand up there or ask, get our attention in some way, shape, or form, I guess is what I'm trying to say. So many different ways to ask questions. It's a fairly small group tonight, so don't hesitate to ask. You definitely want to make sure everyone understands what's going on. If you would rather just type it in, that's fine. We'll save some time at the end of the talk as well. Presentation itself lasts about 30 to 40 minutes, and then I try to save at least 15 or a little bit more at the end as well. And also, we are recording this session too, so just for your information, so we can play it back later on for other folks that can't make it tonight. So that's kind of how the process is going to go tonight. As I said, I'm Sam Deniski. I'm the programs manager with Renew, and one of the programs that I manage is the MadiSUN program. We're going to be talking about that. We're also going to be talking a little bit more about solar power in Wisconsin in general, just to kind of start out with, just to make sure everyone is sort of on the same level of understanding. A lot of people assume that, you know, Wisconsin being kind of a northerly state, we don't get as much sunshine that we need in order to make solar electricity. And it's certainly true that we don't get as much sunshine as some areas of the United States, like the desert Southwest, but we definitely get more than a lot of places, Seattle, the Pacific Northwest, the New England states as well. We also get a lot more solar than Germany. And you might be wondering, well, why is Germany on this map? And that's because quite a few years ago, Germany made a really large investment in solar electricity. They currently get anywhere from about 5 to about 15% of their electricity. Usually it's more accurately around 7% of their electricity. And then they have about 35% of their electricity coming from renewable energy in total. In Wisconsin, on the other hand, we get much less of our electricity from solar, even though we have a much better solar resource at our hands. So the main takeaway that you need to know from this map is that Germany, even though it's located, all of Germany is located further north than actually Wisconsin is, they can still do a fair amount of their electricity from solar, and so can we. We just need to put in the investment. And thankfully, those numbers are going to be going up over the next couple of years, both through utility solar projects and through individual solar projects like solar on homes and things like that. Solar is also very reliable. I know a lot of folks have worries about wintertime and not getting enough sunlight from the shorter days, but solar panels are actually a lot more reliable than I think what a lot of people might think. They can withstand up to golf ball size hail. They can withstand hurricane force winds. And they also do a pretty good job of melting snow, which is, again, kind of a big concern here in the upper Midwest. The panels, as you can see from this animation right here, not only are they strong enough to withstand ice cubes shot at them at a very high velocity, but because they're black and they are typically oriented at an angle to your roof, the solar panels typically stay a little bit warmer. The snow tends to melt and eventually slide off on its own. If we get a relatively heavy snowfall, kind of a heavy snowfall in a short period of time, especially a big snowfall that might be followed by a cold snap, your solar panels will have a little bit of snow that will stick to it, maybe for a few days, maybe even as much as a week. But for the most part, most of the time, like I said, because there's electricity always running through the panels, because they're a darker color, because they're at an angle, the snow typically will melt and slide off on its own. In fact, we really want to stress not to try to remove that snow on your own in some way. Because the last thing you want to do is accidentally damage your panels just trying to remove some snow. Another reason why solar is a viable option in Wisconsin is that it has become much, much more affordable over the last 10 years. The prices have dropped anywhere from 75% to close to 90% in the last decade alone. On the scale of a home solar array, that price is closer to 75%, but still a significant drop in price. And that drop in price on this graph is signified by the yellow line. So as you can see, it's come down quite a bit from over $5 per watt down to just a little over $1 per watt. Our price, not quite that low. We'll talk about that a little bit later on. Those are more for larger utility scale installations. But the main point is that solar has come down a lot. And part of the reason is indicated by these blue bars. And those blue bars indicate the amount of solar that has been installed over the last 10 years as well. So just like any large scale product that gets produced, when you start producing it at economies of scale, you're able to bring down the total unit price by quite a bit. So that's part of the reason why solar has been able to come down so much, is because of the economy of scale. The other reason, of course, is because the technology has improved quite a bit as well. Panels now basically are the same size that they've always been, but the efficiency of them has gone up by quite a bit. We'll talk about that a little bit too as well. Another reason why solar is a really good idea is it is a great investment for your home. This was a study out of the National Renewable Energy Laboratory in Colorado, and it said that across subdivisions, so neighborhoods where houses are relatively the same size, the same age, a home that is outfitted with solar electricity will sell for 20% faster and 17% more than an equivalent non-solar home. So what that means is if you and your neighbor are both selling your house at the same time, they're about the same age and about the same size, your home on average is going to sell for much more, and it's also going to sell much quicker too. So it's really a great example of why solar is not only a good investment for your everyday expenses, but also for long-term expenses and for the value of your home as well. Yet another reason why solar is a great investment is you are investing in your local community. These jobs, solar installer, solar developer, solar technician, these are jobs that really cannot be outsourced. You need individuals, boots on the ground, installing these solar panels, electricians, journeyman electricians, master electricians, installing these solar arrays. And this is why it's not only a great investment for yourself, but a great investment for the community as well. So this graph right here indicates where solar jobs have gone over the last decade as well. And it kind of mirrors the other graph I just had. As we install more solar, obviously we're going to need more folks to do those installations, to put the solar in, to develop the projects themselves, to get them connected and things like that. So again, not only are you investing in yourself, but you're investing in the rest of the community as well. And kind of one of the last reasons I should say, I actually have a few more points. Another reason why people get compelled to install solar is not only are they able to save on their home electric bills, but they're also, in a way, able to save on their fuel costs, on their transportation costs as well. So a lot of folks will do a solar array and an electric vehicle at the same time. It's a pretty easy add-on. In fact, now it's really just a different kind of inverter. We'll talk about the components and the technology in a little bit. But basically, folks are just installing a few more solar panels, anywhere from about 5 to 9 more panels, and that will essentially power their electric vehicle use as well. Obviously, if you're going to do traveling, you're going to have to charge up in other places, but day in and day out. It's a way to save even more money by fueling your car with electricity rather than gas. And by doing that with a solar array, not only are you able to save money just in the fuel costs, but you're also able to save money over the longevity of the solar array as well. And of course, saving money, that's kind of what the crux of the situation is at here. By installing the solar array, you're able to produce your own electricity. By doing that, you're able to lower your electricity bills and also hedge against rising utility prices as well. Typically, utility electric rates rise by anywhere from about 1 to 3% per year. Some years more, some years less. But even if those utility prices were to remain the same, I'm going to show you in a little bit that you're going to be able to save literally thousands of dollars over the course of the lifetime of your solar system. This saving money has become really beneficial to sort of the popularity and the rise in solar electricity. This is something now that a lot of folks are not installing solar necessarily to be green or to swim against the effects of climate change, but they're actually doing it more for their pocketbook, which really helps to show why solar is great and why we can introduce it to more demographics, people on both sides of the political aisle, people of all ages, et cetera, et cetera. Excuse me. So in summary, why to go solar? It works, even in a state like Wisconsin. It has become much more affordable. We're going to talk about that in a little bit here. It increases the value of your home. It also increases the jobs and the economy in your community. You can fuel your vehicle by it as well. And you can also save quite a bit of money in the time. So I'm going to pause just really briefly here just to see if anyone has any questions. If not, we can keep rolling, but I just want to pause for a second, both to catch my breath and to take a sip of water and just to see if anybody has any questions. Okay, great. Then we'll keep rolling. So how does solar work? Solar has actually been around a long time. Some of the first, the photovoltaic effect, excuse me, was first discovered back in the early 20th century. Bell Labs in New Jersey started using it more on a commercial scale in the 50s and 60s, but it really hasn't taken off until about the last 5 to 10 years. So people think that because this this technology is fairly new, that there's a lot to it. It's really advanced, really technologically advanced. And it's actually pretty simple when you get down to it. There's really, outside of the wiring, only 2 main components to a solar array. And those 2 components are the solar modules, as you can probably guess, and the inverter. So the inverter, we'll start with that one. That converts our DC electricity to AC. So the solar panels create something called direct current. The inverter converts that DC electricity to AC electricity, which is what our phones, our TVs, our refrigerators, etc. Mostly run on. So the inverter kind of does the behind the scenes work. They're typically, the warranties on those are anywhere from 10 to 25 years. There's also an option to purchase an extended warranty for your inverters as well. So something to think about there. The other cool thing about the inverters now is not only, like I said, are there some that come with electric vehicle plugins. So the inverter will actually have a kind of like a cord essentially that bypasses that conversion, and it will just take the DC electricity and have it go right into your electric vehicle. So it's a way of really maximizing the efficiency of your solar array. So in addition to that, there are other kinds of inverters as well. A lot of them now, I think all of them pretty much connect to the web or to a phone app for monitoring. So you can kind of keep tabs on what your solar array produces during the course of the day or the course of a year. My own parents actually just purchased a solar array 2 winters ago, and my dad, who had only ever had one cell phone before that, it was a flip phone, was still using it up until 2 years ago, went out and bought an iPhone so he could keep tabs on his solar array, which I think is super cool. So if you're a geek, if you like to nerd out on that kind of data, that's definitely something that can be set up. The other component, as you can probably guess, is the solar panel or solar module. That kind of converts, or that kind of does the main work of the system. It converts the sunlight into electricity. This is a chemical reaction. The solar panel is basically made up of just two different layers of silicon. So because there's no moving parts, because it's just a chemical reaction, there's really nothing to break down, which is why these solar panels are so efficient. There's really no maintenance involved at all. The warranties on all of the panels in our program, there's a few different models to choose from, but all of them have 25-year warranties or more. I like to tell people that, it's just like the warranty on a vehicle. A lot of cars have 100,000-mile warranties. That doesn't mean at 100,001 miles that people stop driving them or that the wheels fall off or anything like that. Most of these panels now, they're warranted for 25 years, but they're going to last for 30, 40, maybe even more years. So because there's nothing to break down, they can last that long. So that's why solar arrays are just becoming so popular, because there's really no maintenance involved almost whatsoever. Here's a schematic of the two types of solar modules that we're going to be using. Each of the different brands and panels has two different sizes, and that's what these are. So all of the small squares within each of these rectangles are what we call the cells, the solar cells. So the big solar panels are comprised of 72 cells. The smaller panels are comprised of 60 cells. Basically, they work in the exact same way. It's just one is a little bit smaller than the other one. The only real reason for that is space constraints. If you have a roof that's, maybe you can fit 2 of the 60 cell panels in where you might only be able to fit 1 of the 72 cell panel in. Otherwise, they're exactly the same. It's basically just, one version is a little bit smaller. So the developers can be a little bit more flexible with their design. So this is essentially what a solar array looks like. And before I get going on that, I want to say that all of the solar arrays that are going to be installed with the Group I are what we call grid-tied solar arrays. And what that means on a very basic level is that you are still connected to the utility grid. So in a normal house, electricity flows in off the power lines, goes through your meter, goes into your circuit box, and then it goes out into your appliances. With a solar array, with a grid-tied solar array at least, what will happen is the sunshine will strike your solar panels. Those panels produce, like I said, direct current or DC electricity. That goes down into your inverter, where again it gets converted into AC electricity. That then flows through your circuit box and then out into your appliances, your electronics, just as a normal house would produce electricity, or consume electricity, I should say. At night, your home will essentially take in power the same way that your house did before you had solar panels. So it will still take it in on the grid, it will go through the meter, and it will go into your appliances. A great thing about having a grid-tied solar array is that essentially there's no real change in your day-to-day life. At night, on very cloudy days, you'll still be able to, turn on your coffee maker or watch TV or stream Netflix or whatever it is you like to do. The other really good thing about a grid-tied solar array is when your solar array produces more electricity than it needs, it will actually send electricity back out onto the grid. So when your solar array is producing electricity, again, the panels produce that DC current. It goes into your inverter, where it gets converted into AC. Then it goes into your circuit box and again out to your appliances. If all of your home's electric needs are being met by the solar, what happens is instead of going through your circuit box, it actually goes back out through your meter and onto the utility grid. So it flows down the street to your neighbor's neighbor, et cetera, et cetera. And when it flows back through the meter, you get a credit for every kilowatt hour of electricity that you produce. Every electron you send down to your neighbor, you get a credit for that. And what your meter essentially will do is it will dial backwards. In fact, I have a great great new animation that I just found about that just earlier, just before we started here. So at night, you know, your meter dials forward just like it would. During the daytime, again, if you're, sorry, this animation's a little faster than I'd prefer it to be, but essentially, when your solar array is producing more electricity than you need and it's putting electricity out onto the grid, it flows backwards. And then at night or on cloudy days or when you need more electricity than what your solar array is producing, it will flow back forward again. And then all you have to do then is pay the net of that meter, which is called net metering. So this is getting more into kind of the policy side of how a grid-tied solar array works, but still very, very relevant. Essentially, like I said, this gives you credit for the extra energy that you produce. That energy can be banked for hours when your solar array is not producing. So let's say, for instance, your solar array produces in a day, let's say 10 kilowatt hours of electricity. And let's say your home uses 12 kilowatt hours of electricity. You're essentially only going to need to pay the utility for 2 kilowatt hours of electricity plus whatever fixed charges there might be. So it's a really advantageous way of using solar. It essentially kind of acts as a virtual battery in many ways. You know, whatever electricity isn't being used, it's going to be used somewhere else, and you're going to get the credit for it. And then at night, you're going to be able to take in that electricity. Granted, it might not be, you know, solar powered or green electricity, but you're going to be able to take it in at a one-to-one credit. So it's really, really advantageous for your pocketbook. We call it rollover electricity. I used to use the analogy of rollover minutes on a cell phone, and I think that analogy has become quite dated, but that's essentially kind of the easy way to sum it up for a lot of folks. I am kind of a visual learner, so this is a visual representation of what net metering looks. The area in red here is this is a snapshot of a real solar array. So this area in red is a home's electric use, and it starts at midnight, goes to 4 a.m., 8 a.m., noon, 4 p.m., and then 8 p.m., and then midnight as well. So again, the area in red is where this home is using electricity in real time. So there's quite a lot of spikes. This might be a refrigerator cycling, or maybe air conditioner turning on or something like that. Then right around 7 a.m., the sun comes up. This person's solar array starts producing electricity, which is the area indicated by the green. A little after noon, the sun peaks, and then it begins to kind of dip in the horizon, and that's when the solar production goes down until right around about 6 or 7 o'clock at night when it sets completely, and then the solar array essentially shuts off. This area in blue here is what we call self-consumption. That's when the solar electricity is getting used by the home in real time. So as you can see, that area in blue is actually pretty small, especially compared to both the red areas and the green areas. This is like a really good visual way of showing just how important net metering is, because a lot of this green would just be going to waste otherwise. And through net metering, we're able to kind of take this green area and fill it in some of the red areas. So offsetting that electricity and offsetting our utility bills as well at the same time. I'll stop there just for a second too, just to see if there are any questions on that, because net metering can get really tricky. Each utility also has different net metering policies too. We can go over that a little bit later, but it's a kind of a tricky subject, so I just want to pause briefly to see if there's any questions. Okay, we'll go on then. A lot of people want to know what kind of home they need for a solar array, and these criteria have actually changed quite a bit just over the last 5 years. I've kind of had to rearrange these bullet points really just in the last 2, to be honest. So it used to be a south-facing roof was absolutely needed. That has become less and less of a concern thanks to the increases in technology and through net metering policies as well. Now, the most important aspect that you need to produce solar electricity for your roof is an unshaded roof. You don't want a lot of trees blocking your view, or buildings, or any other thing that might possibly shade your roof. So you want a clean, open view of the skyline so your solar panels can produce as much electricity as possible. Second thing you want is you want a new roof, or as close to a new roof as possible. Solar panels, like I said, they're warranted for 25 years. They typically last a lot longer than that. They last as long, if not longer, than a typical shingle roof. So ideally, you want to go in with as new a roof as possible, or also a standing seam metal roof. That's actually the best situation. Standing seam metal roofs don't even need any holes poked in the roof as well. They can just sort of wire around it. There's a simple clamp where the solar panels clamp on. So a metal roof is ideal. If you're thinking about solar, if you're thinking about doing a roof at the same time, you should definitely take a look into metal roofs, because they're really advantageous. They'll last for a lifetime and you don't have to worry about them at all. After a roof, again, south-facing roof is best. That being said, as long as your rooftop isn't shaded, east-west facing rooftops are totally okay. There is more than enough opportunity, given the advancements in technology, for those solar cells to soak up enough sun rays in the mornings and in the afternoons, where you can offset basically your entire electric use throughout the day. And I went a little too far ahead there. I apologize. The last point, which is really important that I do want to make, you want an energy efficient home as well. If you still have old incandescent light bulbs, if you still have, a 15-year-old refrigerator, you want to kind of make those upgrades first off. You want to have your home running on as little electricity as possible. That way, you don't have to buy any more solar panels than what you need. You can do a very small array that will still offset all of your electric use and will still be able to save you the most money. So energy efficient home, it's not something we talk about a lot, but definitely something that's still very important when we talk about purchasing a solar system. So that's essentially how solar works. Now we're going to move on into kind of the important part of the conversation that I think a lot of people are interested in, and that's cost. And a lot of that is kind of tied in with our group buy. So being part of a group buy, I guess the main reason why a lot of folks do a group buy is it simplifies the process. We at Renew Wisconsin select the contractor, we figure out the set price, and then we're also there to ask any questions and kind of help you along the way as well. So like I said, we simplified the process, we select the contractor. Those contractors, I should say contractors, two of them this year are Full Spectrum Solar and Midwest Solar. They're both MadiSUN-based companies. They do a great job. We've been partnering with them now for, I think it's 4 years running, might be 5 years running. They do a great job, and these are the set prices this year for them with the group buy. So there's two main options. The first option is North American panels, solar modules that are made in North America. Those panels are $2.93 per watt. Those panels are also a little bit more efficient too. So each of the North American modules will put out 370 watts of electricity versus the imported panels, which will put out 320 watts each. And because they're a little bit lower efficiency, they are a little bit lower price as well. So those are $2.88 per watt. They both make electricity in the same way. A 5 kilowatt system with North American panels is still going to make as much electricity as a 5 kilowatt system with the imported panels. You're just going to need, maybe one more panel or something like that. And these two prices here represent about a 6% discount from what the price normally would be for a system with Full Spectrum or Midwest. Larger systems, which are 8 kilowatts and above, those discounts amount to anywhere from like a 12 to a 17% discount. So some pretty big savings there as well. The average size system is about 5 kilowatts, and we'll talk about that a little bit too. But if you need a bigger system, you're actually going to save a little bit more money too. And then, like I said, the other benefit of joining a group buy is we provide an extra layer of customer support too throughout the purchasing process. So that's kind of the basic price. Now we're going to go into some of the incentives. One of the main incentives that we kind of promote, that we look at, that is available to homeowners in Wisconsin is a rebate through the Focus on Energy program. If you do not know about Focus on Energy, I certainly I implore you to, as soon as this is over, go out and Google them. They have a ton of different programs. Most of them are actually energy efficiency, but they do programs on everything from rebates for solar arrays all the way down to free light bulbs. And if you purchase a solar system, they have a potential for a rebate of $200 per kilowatt. That's capped at $1,000, but so you can potentially get up to $1,000 off of your system through one of these focus on energy rebates. And if you live in a rural zip code, you can save even more money. They do have those rural zip codes listed on their website. So if you do live outside the city of Madison, definitely suggest you go there and see if maybe your zip code is on the list. There are some requirements, however, in order to obtain this rebate. Your home has to be 10% or less shaded, and it has to be within 90 degrees of due south. So that basically means it has to be from, your roof has to slope anywhere from due west all the way around to due south back to due east again. So as long as it doesn't face north and it isn't more than 10% shaded, you should be able to qualify for that rebate. And that's something we can kind of, we at Renew can kind of talk you through as well. We can let you know, at least if it looks like you'll be, less than 10% shaded, and if you, face within 90% of due south, or 90 degrees, excuse me, of due south, that's another thing that we can help you out with. And sorry, my presentation is kind of getting away from me there. The other main incentive that we look at that is available to folks is the federal investment tax credit. Now, last year and for many years prior, that tax credit was at 30%. This year, that tax credit has been reduced down to 26% of the cost of a system. And next year, it will get reduced even further, down to 22. And then in 2022, that tax credit, at least for homeowners, goes away completely. It does still stay at 10% for businesses, but for homeowners, it does go away completely. So we saw a lot of people, a lot of homeowners installing solar last year. We're actually seeing a lot this year as well. We thought, last year there might have been a little bit of a drop off this year because, folks didn't get the 30% tax credit. I think now people are seeing kind of that the writing is on the wall. 26% is still much more than nothing. So a lot of people, a lot of homeowners especially, are doing solar this year. And I think it's part of the reason is because of that 26% tax credit. The way you obtain these rebates, each one is a little different. The tax credit comes when you file your taxes at the end of the year. So for instance, if you installed a solar array this year, you would get the tax credit next spring whenever you file your taxes. The focus on energy rebate comes a little bit more quickly. Once you install your system and it's interconnected and working, you submit an application and then they send you a check. So that one goes pretty quickly. But both of them do sort of go into effect after you purchase the array. So we'd like to talk about the difference between upfront costs and kind of out-of-pocket costs, what it's ultimately going to cost you and how much you're actually going to have to write the check out for when the solar system is installed. And we're going to run through an example of that right now, as a matter of fact. So the average size solar array in Madison area is right around 5 kilowatts. At our $2.93 price per watt rate, that works out to a little under $15,000, $14,650. If you qualify for a focus on energy incentive, again, that's $200 per kilowatt. So that's potentially up to $1,000 you might be able to qualify for. Again, the 30% federal tax credit is no more. It is now at 26%. But if we apply that tax credit as well, that reduces it by a further $3,500, which leaves us with, like I said, an out-of-pocket cost of a little over $10,000. So it goes from almost $15,000 down to almost $10,000. So quite a good deal of savings there, almost a 30%, I think actually a little bit more than a 30% reduction in cost. Again, this is just an example. Every single person's, every individual home and every individual person's array is going to vary a little bit. But this is a good example that we use just to kind of show ballpark figures of what people might be looking at. Any questions on that? I'll just pause for a second here. Okay, so we do have a question that came in. I apologize if oh, no, it did just come in. What happens to the solar array or warranty if a newer roof needs replacement, say hail damage? That's a great question. If your solar panels are damaged by hail, you will have to replace them, certainly. A lot of folks add on, you're gonna have to talk to your individual home insurance provider, just to kind of find out what that is, but essentially, you would add on a small amount to your monthly home insurance bill, and then if those solar panels, excuse me, were damaged in a hailstorm, you would have to purchase new ones. So that warranty does not apply for something like hail. It essentially just is just the regular working ability of the panel. Yeah, the 25-year warranty comes with every panel. There is a warranty on the labor as well. I believe that's 2 years. Morgan, if you're on and if you know for sure what that is, feel free to correct me. So I think the labor, the workmanship is there's a 2-year warranty on that, and then the solar panel warranties are for 25 years. The only warranty that really varies or that you actually have to pay anything extra for would be for the extended warranty on the inverter. And that is a completely optional choice. So, okay. Okay, I'll keep moving on then. If you have questions, feel free to pop your hand up, or I'll put them in the chat function as well. So with the knowledge of kind of what is the average size solar array, how much annual sunshine we get in Wisconsin, we can really calculate what kind of solar production we're going to get, again, on average every year from our solar array. So if we take that 5 kilowatt average, again, that's the average size of an array in MadiSUN. MadiSUN also tends to get about 1,500 hours of sunshine every year. That equals 7,500 kilowatt hours of electricity per year. So what we do is we take that and then we, oops, where am I here? We multiply it by our electric rates. So if you are on a municipal utility, like a Sun Prairie utility, a Wanakee, your electric rate is about 10 cents per kilowatt hour. So 10 cents times that 7,500 gives you an average annual savings of about $750 per year. If you're like most of us, if you're an MG&E customer, you're paying 13 cents per kilowatt hour. 13 cents times that 7,500 is about $1,000. So MG&E customers can expect, again, on average, to save up to about $1,000 per year on a 5 kilowatt array. Again, this is these numbers, the actual numbers change quite a bit depending on, everything from which utility you have to what size array you have to how much sunshine we get per year. If it's I think 2 years ago, I think in 2018, we had a really cloudy year. A lot of people were upset because their solar arrays just didn't produce as much electricity as they had hoped. And it was just because of the climate. We had a really cloudy fall, especially that year. So it was, obviously it was a big disappointment for us. And of course, also certainly for all the people that had installed solar. But again, this is just kind of to give you a ballpark figure of what you're looking at for your solar arrays value. And then now that we know that, we can take that and then multiply it we can divide it, I should say, by our price. And essentially, paybacks can run anywhere from about 7 to 11 years. Again, this will vary all the way from who your utility provider is to how much sunshine we get per year. But the main takeaway, I don't want to get too much into these, into the math and into the figures, but essentially most home solar arrays will pay for themselves in anywhere from about 7 to 11 years. So they will vary a little bit, but that's kind of a really ballpark figure to look at when you're talking about payback and returns on investment and things like that. So if we assume that every solar array is probably going to last for at least 25 years, probably more like 30 or closer to 40 years, this equates to almost $20,000 over the lifetime of the system. And that is not even taking into effect rising utility rates as well. So an opportunity for a great investment here, really to save quite a lot of money over the long haul. So that being said, how does this actually happen? How do you get a solar array installed if you're interested? Well, the first step, many of you have probably already done this, is to log on to MadiSUNSolar.com and click on the I'm interested box. There's a form to fill out that will give us information on your home, on your electric use, and a lot of other things. What will happen then is we'll give you a phone call. We'll discuss, like I said, your home, maybe the direction your rooftop faces, how much shading you have, how much energy you use, things like that. We'll recommend, things like size of the system. We'll give you an idea of what rebates you might be able to qualify for and for the cost and things like that. If all that sounds good, what we'll do then is we'll schedule a site assessment for you. And with the site assessment, one of our solar contractors, again, from Full Spectrum or from Midwest, actually comes out to take a look at your home. They actually get up on the roof and do some more precise measurements. And after that, it turns into a proposal. One of our solar contractors will issue you a specific size, specific type, layout, and then all the potential rebates and eventually the cost as well that you'll get as well. If you like that, the proposal turns into a contract. And after that, the solar array gets installed. This entire process right now can take anywhere from about 5 weeks to 2 months, probably closer on the 5 week span right now, because we're still kind of early on in the summer. That being said, the construction of the solar array will only take a day or maybe 2 in some situations. So a lot of front work. Doing a solar array is very front loaded. You have to design the system. You have to get things like work permits and things like that, construction permits, I should say. But the actual construction of it actually goes really, really fast, which is really, really exciting to me. So that's all I have. I've left a few minutes at the end. I'd be happy to take any questions if you want to type them out. If you want to raise your hand, we can unmute you and you can ask the questions that way. If you're shy, or if you just want to maybe send questions later on, if you have to think about something tomorrow or the next day or the next week, that is my email as well. It's sam@renewwisconsin.org. So I'm going to quiet down now. I'm going to take a sip of water and open up to any questions that anyone might have. So it looks like we have a couple of questions. The first one is about home values, whether they sell for more or for faster in Wisconsin as opposed to nationwide. That's a very good question. I don't believe there are any. That study that I showed you from NREL in Colorado, I think was actually based in California. I don't have any specific evidence, unfortunately, of that here in Wisconsin. I think it's still a little bit too new. Solar has been it's been a much more regular part of the community for a lot longer in California, which is, I think, why they've been able to kind of do some of those studies. So unfortunately, no, I wish I could provide you information one way or the other, but that study, to my knowledge, has not been done yet in Wisconsin. Next question. Does this include the west side of Madison? Yes, it absolutely does. In fact, this year, we've actually gotten our contractors and gotten the city to agree to actually extend this out to not quite all of Dane County, but most of the sort of immediate Madison area. So Fitchburg, Verona, Middleton, Monona, Sun Prairie, Waunakee, all of those all of those municipalities will be included in this as well. So you don't have to be in the immediate Madison area to take advantage of this program. Okay, next question. How is the needed array number determined? That's a great question. So what we do is we take a look at your electricity. Basically see, it depends again which utility provides your electricity, but we take a look at how many kilowatt hours per month you typically use, and then we figure out, kind of going back to that slide just 1 or 2 slides ago, we figure out how many panels you'll need to produce that many kilowatt hours per month. So for instance, my home right now, I use about 450 kilowatt hours per month. I would need right around a 4 kilowatt array, which I'm really bad at mental math, so forgive me, but I think it's essentially, it's about 5 panels worth, I think. Or sorry, not 5, it's about 10 panels worth. So that's how we do it. We just take a look at your your average monthly electricity, figure out how many panels you're gonna need to offset all of that electricity, and that's kind of generally the system size that you'll need. Okay, next question. And if I don't do a good job of answering these questions, feel free to, send me another, a follow-up question in the chat as well. So the next question is, are sample contracts, including information on warranties, extended warranties, available on your website? That is not available on our website. I don't think I have that information. I'd have to see if I was available to make that public, but I guess the short answer is no. Unfortunately, I don't have an example of the warranty information, or sorry, of the contracts or the warranties. I don't know exactly, because the warranties just automatically come with the materials. I don't know what those actually look like on paper, sorry. Yeah, so the next question is, can you explain within 90 degrees of due south? Yeah, so so if you look at a map, north always faces straight up. And then if you go around to the east would be at 90 degrees. Due south is 180 degrees. Due west is 270 degrees, and then again, north is 0. So, or 360, I guess, depending on how you look at it. So within 90 degrees basically means 90 degrees is just at a right angle to due south. So it's, if you look at a map, it's basically from due west, kind of a semicircle all the way around to due east. So as long as the rooftop that you're installing the solar on faces anywhere from west all the way to south, back to east again, and it's not more than 10% shaded, you should be able to qualify for that Focus on Energy rebate. I hope that sums it up. I do a much better job if I have a visual, but it's a lot harder to do over the webinar than it is if I was in person. So I hope that answers. If not, just send me an email and I can definitely answer it via email. These are great questions, by the way. Thank you everyone very much for these questions. Okay, well, I'm certainly happy to stick around for a little bit longer, but if there are no more questions, again, this is, my email is right here. I'm almost always on email. Feel free to shoot me a question anytime. Be happy to answer and get back to you. Again, if you haven't done it, I really suggest you just log on to the MadiSUN Solar.com webpage, and I just lost it there, so I apologize. But yeah, certainly encourage you to go to that webpage. There's a lot of great information on the program there you can check out. That's also where you can go to sign up for the program. And so I highly encourage you to do that. So thank you everyone very much again for taking the time this evening to join us. And I think we'll wrap it up. Thanks.